In this video, we're going to do some more examples of trigonometric equations. Let's look at this first example. Here I have sine of theta is equal to 1 upon 2. And I need to find the values of theta from 0 degrees up to 90 degrees. So let's solve this problem. My first step is going to be replacing my angle theta with my reference angle. So this would be sine of alpha. Alpha is my reference angle, is equal to 1 upon 2. Next, I'll send sine to the other side to find alpha. So alpha is equal to sine inverse of 1 upon 2. So if I use the calculator, since my domain is in degrees, I'll keep my calculator in the degree mode. So this would be sine inverse of 1 upon 2, and that would give me 30 degrees. So my reference angle alpha is 30 degrees. Now I'll draw my 4 quadrants and name my angles. This is 0 degrees here, this is 90 degrees here, this is 180 degrees here, this is 270 degrees here, and back over here I'll get 360 degrees. Since my equation sine theta is giving me a positive value of 1 upon 2, means my sine function is positive, and my 4 quadrants are named as A, S, T, C, and my sine function is positive in the first 2 quadrants. So I'll draw 2 equally inclined lines in my first 2 quadrants. This is my reference angle alpha and this is my reference angle alpha, and this is 30 degrees here, this is 30 degrees here. So now if I start from 0 degrees and turn anti-clockwise, because I need positive angles from 0 to 90 degrees, and anti-clockwise is positive measure of angle. So I'll turn anti-clockwise from 0 degrees and go up to my first line, this line. And since this line is equal to the reference angle, so my first angle is going to be 30 degrees. Now if I again start from 0 and go up to my next line, this is going to be my second value of theta. And this angle is 30 degrees less than 180 degrees. So it would be 180 minus 30, which would be 150 degrees. So the next value of theta for which sine theta is equal to 1 upon 2 can be 150 degrees. But the domain is given to me 0 degrees to up to 90 degrees. So I will reject this value. So my only answer from 0 degrees up to 90 degrees is this angle. So my answer is going to be only 30 degrees. Another way to look this is that if I draw my graph of sine function, which looks like this, this is the graph of the sine function from 0 degrees up to 360 degrees. But this graph continues on forever, and it also continues on in the negative axis. And this is my value of 0.5, let's say, suppose over here. And over here I needed to find the values of theta. Theta is on the x-axis. I needed to find the values of theta that would give me the value of 0.5. So I would get these values. So if I keep on drawing my graph, I would get infinite amount of values for this 0.5. But since I'm restricted to this domain of 0 degrees up to 90 degrees, which is over here, I get only this value, which is 30 degrees. So this is my answer. Now let's move on to the next question. In the next question, it is told that cosine theta is equal to 1 upon 2. And I need to find the values of theta from 0 degrees up to 720 degrees. So let's solve this question. The first step is going to be replacing theta by my reference angle alpha. So cosine alpha is equal to 1 upon 2. Next I'll send cosine on the other side. So alpha is equal to cosine inverse of 1 upon 2. And from the calculator, if I calculate this, cosine inverse of 1 upon 2 would give me the value of 60 degrees. So my reference angle alpha is equal to 60 degrees. Now I'll draw my 4 quadrants. These are my 4 quadrants, which are named as A, S, T, C. This is 0 degrees here, this is 90 degrees, this is 180 degrees, this is 270 degrees, and back over here 360 degrees. From the equation, I can see that the cosine function is positive. So I'll need to look in which of my quadrants is the cosine function positive. Obviously, in the first quadrant, all trigonometric functions are positive, so this equation is valid for this quadrant, and in the fourth quadrant, the cosine function is positive. So this is true for this quadrant also. So I'll draw two inclined lines in both of these quadrants. These are going to be my reference angle. Remember, the reference angles are always measured from the x-axis. So this is going to be 60 degrees and 60 degrees here. So if I now start to measure my angles from 0 degrees, I am going to turn anti-clockwise because here I need positive angles and anti-clockwise measure is positive measure. So this is going to be my first solution of theta, which is equal to the reference angle. So my first answer is going to be 60 degrees. And if I again start from 0 up to the next line, it's going to look like this. This is 60 degrees short of 360. So it's going to be 360 minus 60, which is 300 degrees. Now I measured these two angles from 0 degrees all the way up to 360 degrees. But I need to measure my angles from 0 degrees up to 720 degrees. If I visualize this on the graph, this means this is my cosine function, which looks like this, and I've drawn this from 0 degrees up to 360 degrees. And if I keep on drawing it after 360 degrees, it would look like this. This is my y-axis and this is theta. I need to measure angles from 0 degrees up to 720 degrees. And here I have the value of 1 upon 2. So 1 upon 2 is going to be somewhere over here. And I need to find the corresponding values of theta that give me the value of 1 upon 2. So this is going to be this. And I measured this value, which over here is 60 degrees. So 60 here. And I measured this value, which is 300 degrees. So 300 degrees. But I found these values only by finding the angles from here up to here. I need to check the values from 0 degrees up to 720 degrees. And 720 is going to be somewhere over here. And that would give me two more values of theta. So I need to find all the four values from 0 degrees up to 720 degrees. I found 2 out of 4 values. So to calculate these two values, what I'm going to do, I'm going to start again from 0 degrees and go all the way up to 360 degrees and go past this 360 degrees up to this line of the reference angle. This is going to be my third value of theta. And since one complete cycle is 360 degrees up to here, then this yellow angle is 60 degrees greater than 360 degrees. And 360 plus 60 is equal to 420 degrees. So this angle over here is 420 degrees. This is my third angle. Now to calculate this fourth angle, I will again start from 0 degrees and go past this 360 degrees and go past the second line because I've already found the angle up to this line. So I'm going to go up to this next line over here, this line. So what is going to be this orange angle? Well, if I draw this neatly over here, this is my line. This orange angle looks something like this. And this is 0 degrees here, this is 90 degrees here, this is 180 degrees here, this is 270 here, and back over here I'll get 360 degrees. We know this is 60 and this is also 60. So when I start from here at this line over here, I would get 90 degrees. At this point I would get 180 degrees, and at this point I would get 270 degrees. At this point over here, I calculated this angle, which is 300 degrees. So 300 here, and at this point, this is one complete cycle. So at this point, I would get 360 degrees. And at this point, which is 60 degrees greater than 360, I would get 420 degrees. This is my third angle. And up to here, up to this point, I would get 360 plus 90 degrees because this is 90 degrees here. And 360 plus 90 is 450 degrees. So up to this point I would get 450 degrees. So at this axis I get two angles 90 degrees and 450 degrees. Now if I move on up to this point I would get 360 plus 180 degrees, which is 540 degrees. So this is going to be 540 degrees. And up to this point I would get another 90 degrees, and 540 plus 90 is 630 degrees. So 630 degrees. So here I would get 630 degrees. And if I go back up to this line, this would be 630 plus 90, and 630 plus 90 would give me 720 degrees. Back up to this line, 720 degrees. So I can write here 720 degrees for two complete rotations. So I can write this over here. One complete rotation gives me 360 degrees, and two complete rotations are of angle of 720 degrees. Now this angle over here, this white angle, is 60 degrees short of 720 degrees. So my fourth angle is going to be 720 minus 60, which gives me the value of 660 degrees. And if I were to go up to this next line, this would cross 720 degrees. And since my domain is up to 720 degrees, I would not calculate more angles. So these are my answers. Now let's do the last example, which is tan theta is equal to minus square root 3 upon 3. To find the values of theta in this domain of 0 degrees up to 270 degrees, first I'll replace theta by alpha. So tan alpha is equal to minus square root 3 upon 3. And if I send tan on the other side, I would get alpha is equal to tan inverse of minus square root 3 upon 3. And to find this tan inverse minus square root 3 upon 3, I'll use the calculator. So tan inverse of minus square root 3 upon 3 would give me the value of minus 30 degrees. So alpha is equal to minus 30 degrees. So if I draw my four quadrants, and these are named as A, S, T, C. In my question, it is told that tan theta is equal to minus square root 3 upon 3. So tan theta for this angle theta gives me a negative value. So I need to look in which of my two quadrants is my tan function negative. In the first quadrant, all are positive, so I cannot draw a line here. In the third quadrant, also tan functions are positive, but it's negative over here, so I'll not draw a line in this quadrant. In the second, only sine are positive, so tan would be negative here. And in the fourth, only cosine are positive, so tan would be negative here. So I'll draw two equally inclined lines in these two quadrants. And my reference angle is going to be this alpha, and reference angle is always measured from the x-axis. My reference angle is minus 30 degrees. And minus angle means clockwise rotation. So from 0 degrees, if I rotate clockwise, this is minus 30 degrees. But for reference angle, we are only concerned with the size of the angle, not the direction. So I'll just write 30 and 30 here. And if I start from 0 degrees, if I start to measure in the anti-clockwise direction, because I need to find positive angles. So this is going to be my first angle. And if I again start from 0, this is going to be my second angle. For my first angle, this yellow angle, it's 30 degrees short of 180 degrees. So my first value of theta is going to be 180 minus 30, which is 150 degrees. And my second angle is 30 degrees short of 360 degrees, one complete cycle. So it's going to be 360 minus 30, which is 330 degrees. But this angle is crossing my domain, which was up to 270 degrees. And since I needed to find angles from 0 degrees up to 270 degrees, I cannot make an angle that crosses this line. So my only answer in this range from 0 degrees up to 270 degrees is this angle here. So this is my only answer for this question.